This is an introductory video to the Green Rhino building system, a unique sustainable building system. We built in the outskirts of Phoenix a Santa Fe style house some years ago using this system. We built a guest house on a property in North Scottsdale. We've experimented with this. We finally have our testing done and we're ready to go. We did a Santa Fe style saloon for a fellow. It turned out beautifully. Once we had our engineering report completed and we could build in all 50 states, we did a warehouse for a gentleman. We started off some years ago with tiny houses and micro dwellings. This was the Shemer Tiny House Show in Phoenix. We had volunteers show up on the weekend. They cut foam, they glued it together, they had an absolute blast. Here you see a little bit of wood framing that we included in this structure so we could mount windows and doors. We had volunteers that showed up and helped us put on the mesh and the plaster. They had a blast. Here it's completed now, or the exterior of the Green Rhino structural cement is on, and the only thing left is to put on the color. We put the windows and doors in. You can see the structural cement still wet. It cures in a very short time because of all the polymers and resins. We did a synthetic stucco with the color in it, troweled it on. It was complete. Now, the way this goes, we put together an anchor wall first. It adheres to your foundation by pressing this anchor wall down over the rebar that's attached to the foundation. We then, but you can see all the walls, anchor walls are already in on this house. We've weighted them and they've cured. Now, we cut little pockets between the rebar so we can bend that rebar in and then fill that full of grout. We've got a picture here showing that rebar bent into the pocket, and we'll pour that with a non-shrink grout to hold that down. It'll never come up with high winds. Once that's done, we start going up in 4-foot lifts. All of the panels go in, they're 16, 24 feet long out of the factory, and they glue on. We'll weight them a little bit to get a nice tight glue joint. We'll put another panel on to get up 9 feet if we have a 1-foot anchor wall, 10 feet if we have a 2-foot anchor wall. This house is almost completed with all of the walls, and we're getting ready to put the roof on. Very simple, just a few men put this all together. The roof panels are sitting in the garage, ready to go. Here's an aerial view of it. Now, in a few places we might need to put a beam. So we'll have a concrete column coming up from the foundation and a Simpson hold down at the top. The men here are putting on the roof panels. Very simple. They're simply gluing them in place, putting straps on them and pulling them together tightly. Quite a few shoring posts are used in this stage of the operation, but once it's all together and glued tightly, they'll take those shoring posts out and take all the straps off. You're left with a complete foam house. The foam is 98% air on this, an incredible insulation, 80% more energy efficient than a normal house, and very, very easy to work with. You can see this house is quite large. All of these panels went together very, very easily. Now, you can do different shapes and things with this foam. Here we had a bunch of scrap left over. We did a beehive in a little dining area. We wanted a barrel vaulted kitchen over this area, so we cut these at an angle. The windows simply glued in, and then we sanded to get that rounded look. We added a nook in a bedroom, so we arched this thing, put a bunch of scrap foam in there, and did a nook for it. The plumbers and electricians were a little skeptical, but we won them over right away. A hot wire grooving tool, we simply grooved out the foam, kept these scraps off to the side because after inspection we're going to put them back in. Structured wiring went in just as easy as could be. This worked out very, very well. Plumbers and electricians loved it. A ceiling fan, we mounted a pan box to a piece of wood, glued that in all the way around it. We glued some more wood in the wall to accept the cabinets, so when they shim out the cabinets, they can just screw them right through our material into the wall. Now, we use different meshes for different applications. This is a non-bearing wall. These are structural panels on the ceiling and on the walls, so this is our high tensile strength mesh that we have specially made for us. And this goes on with there's a 1/2 inch of the structural cement with this mesh embedded in it. Very, very strong. Okay. This building was 24 by 48, quite a large building with 20-foot spans on it. And we just had a couple of workers putting this together with us. Here they're putting on the mesh on the exterior, and now the plasters have taken over after all the inspections are complete. They're plastering on the first coat. About a 1/4 inch will go on, get that embedded into the wall very well. With all the polymer and resin, it sets up very quickly. This was done in a morning before lunch with 2 guys. They just have a little bit more to go. Now, once the first coat is cured, that 1/4 inch, the fellows are putting on another 1/4 inch. That's a little more intricate. Now, once that was done, this building took a synthetic on the interior. They sprayed it on. We started off with the fire test. We had to pass this before we could move on to anything else. The people at the lab at Intertech were amazed. They thought because this was simply foam and a structural cement, that these intense flames that you generate for these tests, they thought that this thing would just crumble. There was no way. We knew what we were doing here. This was cleaned out. The guys looked at it. They were absolutely amazed. On from there, we went to do structural testing. Our criteria called for full-scale structural testing. So if we wanted to do a 20-foot span or 24-foot span, we had to test a panel that size. Now, it's just sitting on the rack. We cover it with a big membrane and do a full-scale distributive load test. We had to pass these tests for earthquake. So we put it in an earthquake rack. We had to pass tests for freeze and thaw, water infiltration, so we did that. We put them in giant racks and squeezed them and twisted them and just absolutely whatever the engineers wanted us to do to pass these tests. This was one we just kept going. Once we passed the test, I wanted to see how it would break. It never did break. These are some conceptual houses that we drew up. This one's called a multi-sloping house, where you've got a steeper slope of a roof, clear story windows up above, and then a gentle slope coming off. A flat roof can be done with this very, very easily and can take tremendous loads. This could be built in the mountains and that. Now, if you're interested in this, send us your design, email us, look at our website, give us a call. We'd love to talk to you. The Green Rhino Building System. Don't forget it.